Hello, I'm Santoshi, and my teammate is Satvik, and my project name is Fraud Detection in Transactions, where we have a dataset CSV file contains financial transaction details to identify fraud transactions based on the features such as transaction type, amount, and balances. Here we use libraries called pandas, numpy for data manipulation, and mathpy library, cbond for visualization, and some other libraries from machine learning we use in this. Here there is a path to access through the data, and here we checked all the null values to ensure the data set is clearly accessible or not, where we have transaction types, those cash in, cash out, debit, payment, and transfer, so on. These observations, we have each type varying different proportions, revealing insights of the transaction frequency. And we have, from the next chart, we show two types of visualizations. Those are pie chart and bar graph. If you see the screen, the pie chart has like different transactions, like cash in, cash out, transfer, payment, and debit. The different transactions shows different, like different it shows different. In the pie chart, cash in shows like the less color, comparatively cash out, we have differentiate with the different colors. If it is like cash out and oh sorry, if it is like cash out or debit, like more risky, the more risky things we have shown in the brighter colors, with the less riskier things we have shown the less colors for that. Where if it is the in the but in the pie chart, transaction type ratio shows the percentage difference among the transactions of different types, where in the bar graph counts the transaction type and highlights the types of which are most important, such as cash out and payment. And the next part is like we this is the risk category, where transactions are grouped into risky for the cash out or transfer, where non-risky is like cash in or payment. It is visualized using pie chart and bar graphs. And after that, like if you see in this figure, the red chart shows the red plot shows the like high risky, and the green plot shows the low risky, so that we differentiate with different colors in it. And the next one is like fraud analysis, flag transactions among about the threshold amount for like less than uh, like greater than 30,000 30,000 were flagged as the potentially fraud. Only transfer and cash out are marked as frauds, where the here is the statistics for the percentage of fraud transactions compared in total, and distribution of fraud versus genuine transactions. In the pie chart, the risk ratio by amount and distribution fraud and non-transactions, it's shown in the pie chart and bar graph. From here, my teammate Satvik gonna continue.
Here, skewness means asymmetry of probability over the distribution. In the positive screw, uh, it indicates the long tail right, whereas the negative screw indicates the long tail left. Where a screw of 0 indicates the symmetric distribution. It analyzes the uh, skewness and kurtosis of the transaction. We gain insights of the distribution, amount, and the identify the asymmetrical pattern data. It creates the histogram to the visualization distribution of the transaction amounts, and it also creates the skewness of the distribution. The skewness of the value is displayed by the label indicates the how the distribution of the taken place. Here the shows the skewness value is less than or equals to the 0. Inquiring by plotting. Here the here the code applies the transformation of the amount column into the intention of the reducing the skewness values. Here the new distribution part is taken place by the visualizing the symmetrical shape compared to the preserving the label that shows the plot skew values and calculates the values to the 0 as shown in the previous. The box plot helps to visualize the quartiles in the transaction type where it shows the outliers in the certain range, like it shows the outliers within the range of the transaction where it can detect the fraud transactions of the transaction types like cash out, debit, transfer and payment, where the transfer that can seen in the outliers as the output. Plotting confusion correlation matrix and related to the numerical values, where it generates the heat map to visualize the relationship between the numerical features in the dataset. It also calculates the correlation between the each pairs of the features as resulted in the correlation grid. Here the warm colors represent the stronger correlation, mm, and positive correlation comes under the stronger colors, and the white color is represented as the no correlation. Here the code is used as the pre-processing modeling for the risky transactions which is takes under place in which is takes place the relationship of the features. It also shows the calculation by detecting the fraud using the error balance, um, or original and dest. This it also shows the it also shows the heat map of the scatter plot using these correlations within the fraud detection methods. Here are the some numerical values that are shown in under the heat map within the amount and error balance test, where it can take displays the length of each bar on the x-axis and ability to on y-axis. Here the modeling the XGBoost creates the straightforward of 5 folds, which is validation object where it ensures the each fold as an object where it can analyzes the like length of the bias variance trade-off and the potentially adjust the uh, length of the learning curve indicates the slight underfit model. Across the hyperparameters, which is used to perform the generalizabilities. Yeah. Here is our conference paper on the overleaf, which is given in the. Our title is based on the fraud detection in the transactions. Here are the main
This
part of.
is the IEEE paper we done through the overleaf.
Mhm.
Yeah. Thank you.
Thank you.